Hello everyone, and welcome back to our series about teaching maths in the FET phase, that is grades 10, 11 and 12. Let's first take a look at our video on the topic of arithmetic sequences. Sequences and series are used extensively in the banking industry. When a bank lends money to buy a house or a car, they use sequences and series to calculate your monthly repayments. They recover the loan amount plus interest at the end of the loan period through a fixed number of monthly installments. At Thokoza High School in Natal, the teacher, Mr. Letuktula Shabalala, is introducing arithmetic sequences to his learners.
A sequence is just a list of numbers, and an arithmetic sequence is a list of numbers that are connected to one another arithmetically.
The intended outcomes of the lesson for the learners are to use a test to identify an arithmetic sequence, develop a formula for the general term in an arithmetic sequence, find any term in an arithmetic sequence if given the first three terms.
Can anyone tell me what is a triangle?
A triangle has got three sides.
We use triangles whenever we want to form quadrilaterals. Do you know what is a quadrilateral?
Quadrilateral is a four-sided figure.
In the first activity, the teacher will describe the development of an arithmetic sequence by getting his learners to do an exercise with matchsticks. They are asked to create a triangle.
Out of that triangle, form a quadrilateral. How many matchsticks have you used to form a quadrilateral from a triangle?
2 matchsticks.
Learners are now required to make the sequence of shapes.
And then fill in the table for the first 5 shapes you have made.
The table contains columns showing the different quadrilaterals made. It also contains rows showing the amount of additional matches used to make each quadrilateral and another row showing the total number of matchsticks used to make the shape. The teacher has started with a practical example that clearly links sequences to counting.
These learners learn more when we do things practically. So all the lessons need to be done practically, so for them to understand, more.
From the table, we see that to make each additional shape, 2 matchsticks are added. This is known as the common difference. The teacher goes through the table with the learners.
How many matchsticks did you use to form the second quadrilateral?
7 matchsticks.
How many extra matchsticks are needed to form the third quadrilateral?
2 matchsticks.
And the number of matchsticks used to make up the shape of the third quadrilateral?
9 inches.
To the fourth quadrilateral, the extra matchsticks needed?
2.
The teacher explains that the sequence of numbers is an arithmetic sequence if a common difference exists between the numbers. He demonstrates on an arithmetic progression.
2, 4, 6, 8. Up till the end term. If you want to say that this is an arithmetic sequence, there must be a common difference. So is 2, 4, 6, 8 a common, an arithmetic sequence? Yes. Why?
Because there is a common difference of 2.
How did you get the 2?
The second term minus the first term, and I get 2.
It is clear from the table that our sequence is an arithmetic sequence. The teacher will now use the table and together with the learners develop a formula. He begins by defining the terminology.
We have formed the first quadrilateral, right? We will say that is our first term. The first term, it is referred to as T1, first term, or it is A. Whenever you want to form the next quadrilateral, you've been using 2 matchsticks, okay? So in arithmetic sequences, that is called our common difference.
Now that the terminology is defined, the formula can be developed.
Looking at the table, we said our first term, or A, is equals to 5, right? And the common difference represented by small letter d is equals to 2 to get to the next term, which is T2. You said T2 is equals to 7, right? How did you arrive at 7?
From one quadrilateral, we add the common difference, which is 2.
The teacher writes this formula as T2 is equal to A, which is the first term, plus D, which is the common difference.
How did you get now to the third term, which is 11?
A plus 2 times common difference.
The third term is the sum of the first term and 2 times the common difference. What about the fourth term? The fourth term will be equal to
A plus 3 times the common difference.
A plus 3D.
Now that the learners have established the pattern, the teacher gets them to predict something that is not on the table.
What about the ninth term?
Ninth term is equal to first term plus 8 times common difference.
They can now develop a general rule.
This means that if you want to get to the nth term, what did you say will be your nth term?
The nth term would be any term in the sequence.
Tn is equal to the first term plus n minus 1 times common difference.
The nth term is equals to the sum of the first term and n minus 1 times the common difference.
In this formula, A is the first term, Tn represents the general term, n represents the term number, D represents the common difference. The teacher and learners test the formula on the 10th term, which is 23.
What is your first term?
5.
Plus n, which is the number of terms?
10.
10 minus 1. What is your common difference?
2.
2. Then you 18.
After substituting, the answer comes to 23.
So the formula works. You can use this formula if ever you want to calculate the nth term. Do you understand? You can also use this formula if you want to calculate the what? The first term, given the nth term, okay? You can also use this formula if you want to calculate the number of terms. We need to move away now from content-based learning. You know, just telling learners about arithmetic series of which they don't understand exactly where is it working in real life situations. So we need to move to outcomes-based education. Whatever we teach, we need to associate it with what is happening in the real life situation. Nuts for You is a small business that sells snacks at taxi ranks. Miss Tembi Kumalo.
In this activity, the teacher gets the learners to apply what they have learned to a real-life situation.
She set herself a target that the profit her company received would increase by 100 rands every month. She starts with a profit in her first month of 1,500 rands. Assuming she succeeds in her vision, determine how much profit Mrs. Kumalo will be making after 1 year.
The teacher emphasizes that this will be the profit per month after 1 year.
She starts with her profit in her first month of 1,500 rands. Is that the common difference or the first term?
1,500 is first term.
What about the 100 rands every month?
100 rands represent the common difference.
So now can anyone come to the chalkboard and calculate the profit that Ms. Kumalo will be making after 1 year?
N term represented by the sum of months, which is 12 months, equal to the first term is equal to 1,500 plus the number of months, which is 12, minus 1, times the common difference, which is 100.
The learner has calculated that after 1 year, Ms. Khumalo will have made a profit of 2,600 Rand per month. In question 2, learners must determine how long it will take before Ms. Khumalo's profit exceeds 10,000 Rand per month.
Is it the nth term that we are supposed to calculate now? Or is it the first term? Or is it the number of terms? Or maybe is it the common difference?
We are supposed now to calculate the number of terms.
The number of terms. So is 10,000 rands representing the nth term or the first term or the common difference?
Nth term.
What is our first term?
1,500.
What is our common difference?
100 Rand. Instead
A learner substitutes the values on the board.
of 10,000. And T1 is 1,500 plus n minus 1. The common difference is 100. 86 months.
So it means that for Ms. Khumalo, for her profit to exceed 10,000 rands per month, it will take 86 months.
Many teachers and learners find arithmetic sequences and series a difficult concept to grasp. It does, however, lay the groundwork for the more complicated mathematics involved later in geometric sequences and series.
They fail to understand that sequences and series are things that are around them. It should be for educators when they teach their topic. Mainly they try and relate it to things that are far-fetched from the learners. They relate it to things like depreciation of motor cars, yet the learners are in deep rural areas. They don't understand the context. So the best will be for educators when they design these topics is actually the activities on the topic. They should look at things that are around the learners, the immediate environment of the learners, to make it as easy as possible.
Now that we've seen the video, it's time for us to welcome our guests in the studio. We've got Taska Matlejwane from Pafahang Secondary School, we've got Paul Apelsami from Diversity and Transformation Solutions, and we've got Smangaliso Twala, who's an independent maths consultant. Thank you for joining us.
Thank you.
First question to you, Taska. Why was the activity with the matchsticks of value to the learners?
Yeah, the activity was valuable in my view to the learners because for starters, I think learners need to have practical, and then they become more involved when they handle things physically, and that brings about motivation and also brings the element of connecting maths to real life. It makes learners to feel that maths that they're doing is not just theory, but it's something that which they can even handle with their own hands.
Okay, Paul, add to that?
Yes, I think interestingly enough, the idea of using matchsticks, I'm just not sure it would be apt in a school setup where one has to be concerned with fires and so on. But I think the idea of using a practical example to introduce sequences is there. Maybe the kind of tool, plastic, which would have prevented any negative implications around the use of matchsticks. I would just perhaps make that suggestion around that.
Okay. Smangaliso?
You can see that the lesson has properly been planned because of the fact that there are some material. In most cases in senior classes, teachers just go in and barge and they don't do the proper planning and relating everything to real life, like my colleagues have already said.
Okay.
I would have also left out the reference to quadrilaterals in that use. For one particular reason, there may be a confusion between sides of quadrilaterals and the number of matchsticks that were in use. I would have used the matchsticks, but left out the reference to quadrilaterals altogether.
So to avoid confusion.
That's right.
Okay. The next question, do you think the way the teacher moved towards the formula for a general term in an arithmetic sequence was effective?
Okay, I think there's two aspects here. The practical introduction, I think, certainly good. We're drawing in from a practical base into a more formal structure. However, I think the teacher lost an opportunity to introduce some formal sequences. Okay, sequences are not based on just matchsticks. And therein we may lose that particular opportunity to say, yes, there are several sequences that can be constructed. So if you take that practical work with kids in their groups, why not ask them to form their own sequences now, leaving aside the matchsticks? Okay, let them just come up with other sequences. And then the movement to the general term. Now, the movement to the general term is a progression. It's a progression from pupils seeing that sequences display a particular property. Okay, I would have first constructed a general sequence. I would have constructed T1, T2, T3, T4, and then also alluded to the fact that n is a natural number. Okay, so we have T1, 2, 3, etc., going up to Tn. And also herein, I would have also introduced the fact that sequences are not always finite. They could go on beyond the finite to infinite sequences. So I think the teacher lost a couple of opportunities to introduce a well-rounded concept about this sequence. And then the introduction of A, related to the first term. The introduction of D. Again, the introduction of D was confined very much to T1 and T2, which I'm a bit problematic with, because children tend not to check through.
Okay.
I think he needed to have done a little bit more to show that this formula is generated from a wider set of properties.
Okay, add to that, Ismail?
I would also add that I think he moved a bit too quickly to the generalization of, or to the formula. And I'm not so sure that the children really understand what those sequences and series are all about. It's more like road. You have to get to this point as quick as possible, and that creates a problem. I would have liked it to just happen maybe with the matchsticks, like Paul said, and let's say that's the first case, and then we have another case where the children will just be looking at the sequences and series, and then we move on to another one, a third one, maybe, before we could actually move on towards the formula. And we ask the children, what is it that they see? How do they get to this generalization? What is their own generalization? At the end of it all, they will still get the same formula, but it's just giving them enough real-life situations to solve or to deal with, then they will be able to move into that. I think it was too quickly.
Okay, would you agree with that, Tesla?
Yeah, I fully agree with that. He missed an opportunity in terms of not putting more examples and offering learners an opportunity of experiencing this themselves.
Now, learners have a difficulty with arithmetic sequences, but what are the main difficulties, do you think, Smaga, and how should teachers help them through them?
I think we've just cited some of those things that are actually giving you a problem. Teachers moving too quickly through the whole exercise or lessons. They're looking at their time, it's 30 minutes or 40 minutes, and within that time they want to finish whatever they're doing.
Any other difficulties that learners could have?
Planning on the side of the teachers. Most teachers don't plan these things. They simply say, the textbook is there, and then I just follow it as it is. In almost any case, you would actually find some sequences and series in real life, and teachers don't use that to build on and so that they could continue with their lessons.
Okay.
The classification of arithmetic sequences in terms of the common difference is crucial for learners to be able to classify. Again, my point is it's not being checked throughout the sequence. It's being checked at the T1, T2 level, and yes, it's arithmetic. Now, we know from experience and from testing and so on that we will put in those cases where children will find a D, but it's not necessarily a D. It may work out to an R, a common ratio, as in geometric sequences. I feel that, again, those kind of things should be sounded off at this particular point, which is just not happening in that lesson.
Okay. Taska?
Yeah, I would say a part of the problem that which learners often experience or inherit in a lesson is the language used, the definition of concepts. For them to start understanding precisely what they mean by the Tn, the nth term, because Tn can mean quite a good number of things. And unfortunately, this is set in the same context most of the time. Tn meaning the general term, Tn meaning the last term, Tn meaning the something else. So it is important for the educator to sort of define those things properly and offer learners an opportunity to experience this, the sequence as it goes. And I'll come back to what Paul is saying. Say, they shouldn't see it only from T1 and T2 in terms of trying to define or to create what they call a common difference.
Okay, the next question. What do you think of the balance between group work and the use of the chalkboard in the classroom?
Group work is a very powerful instrument, but I don't think maybe in the lesson as we had been watching it, it was fully utilized, that opportunity. Group work has a lot of advantages in terms of, building up, building maths. The concept of learners, constructing knowledge, it's very important. And that's an opportunity that which is mainly targeted at when it comes to group work.
Yeah, and just one other addition there. In the second example where the teacher calls a pupil up to the chalkboard, there was an opportunity to get another pupil to construct the sequence first, to write the sequence out on the board because it was not constructed. So we could have constructed the sequence first and then went into the actual application in terms of solving that particular problem. And again, I feel that the group work was not fully utilized. We could have had groups come up with their own sequences. And I think of particular note here is that there's no variety. I mean, sequences can have variables in them. That's not ever introduced at this level. Maybe it's early, but I think you need to show pupils that sequences have all of these forms. And in an introductory lesson, I think it's the right place to do it.
There was an opportunity for the teacher when he wanted to go on to the children to solve a particular problem. And that's the time when he should have said, in your groups, how would you do this? How would you have solved this problem? And then we'll be able to see a variety of strategies that the children would have used to solve the particular problem. I don't believe they would have solved it the same way, all of them.
Okay. Any other issues you'd like to raise, starting with you, Paul?
A notational issue that I picked up, the capital N and the small letter n. Now, notation is important in keeping maths consistent with standards and norms. And I see there's a bit of the use of both, which is confusing for the student. In a natural number sense is capital N, small letter n is used to refer to the nth term. So I feel the notational use was not properly adhered to. Also, the actual applications. We could have shown people how to construct sequences as a first level, shown them how to calculate A, how to calculate D, how to calculate Tn. The progression in terms of the application, I think, is a little bit missing from there.
In most cases, what the teacher was doing was he wanted a particular answer, and the answers that were given do not actually show that the children had to think. He was not actually challenging the student with his questions. The questions would be, what is the first term? And the child would just say, it's this one, and it's written already, it's there. And that is not actually challenging the children. And I feel that he wasn't dealing properly with the learners' responses. He doesn't follow whatever they say by a question that will actually make the children think about what they're saying. Things like, why do you say it so? How do you know it was supposed to be like that, and so on?
Just a point about sequence series. Often when we introduce this topic, it's introduced as sequences and series. And it's used interchangeably at the outset because the definitions are not clear. Now, there's nothing wrong with showing the parallel to a series at this point. People can do sums, We don't have to go into the question of arithmetic series, but I'm saying that the parallel between a sequence and a series should be discussed, and the terminology and the definition sorted out at this point.
Okay, well, that's all we have time for this session. Thank you for joining us. Thank you, our guests. That's Taska, Paul, and Smangaliso. And thank you to our viewers at home and at schools for joining us. Do keep your eyes peeled for Module 20. Thank you for watching. Goodbye.